Hello, I'm Sri from CPTU. CPTU presents a course on Amazon Web Services. Section Amazon Kinesis, Kinesis Data Streams. Amazon Kinesis makes it easy to collect, process, and analyze real-time streaming data for great insights and hidden potential in the information. With Amazon Kinesis, you can ingest real-time data such as video, audio, application logs, website click streams, and IoT telemetry data for machine learning, analytics, and other applications. Amazon Kinesis data streams collect and process large streams of data records in real time. You can create data processing applications known as Kinesis data streams applications. A Kinesis data stream application reads data from data stream and it can send the processed records to consumers. Consumers and the BI tools analyze the data for exploring the great insights. Amazon Kinesis capabilities: capture, process, and store video streams, capture, process, and store data streams, capture, transform, and load data streams into AWS stores with Data Firehose, process data streams in real time with SQL with data analytics. Amazon Kinesis is under analytics. Amazon Kinesis video streams. Take input from camera devices, stream video to AWS using the Kinesis Video Streams SDK. Kinesis Video Streams ingest, stores, encrypts, and indexes video streams for real-time and batch analytics. Output finds used in Amazon Recognition Video, Apache MXNet, TensorFlow, machine learning frameworks, etc. Amazon Kinesis data streams capture and send data to Kinesis data streams, which ingest and store data streams for processing. Processing tools such as Kinesis Data Analytics, Apache Spark on EMR, customized code on EC2, and Lambda functions. Build custom real-time applications using Kinesis Data Analytics, stream processing, Apache Spark, or customized application code, or customized code, or Lambda functions. Analyze derived streaming data with BI tools for insights. Data Firehose. Capture and send data to Kinesis Data Firehose, which prepares and loads data continuously to the destination data stores you choose. And the data stores are S3, Redshift, Amazon Elasticsearch Service, Splunk, or any other store. Analyze the streaming output data with analytics tools. Data analytics. Capture streaming data with Kinesis Data Firehose or Kinesis data streams and send to Kinesis Data Analytics, which runs standard SQL queries on data streams. Analytics tools and BI tools can use the processed data from Kinesis Data Analytics to find the hidden potential in the streams of data. One of the most useful use cases is match the suspected vehicle number in the streamed video feeds. As we have seen, Kinesis services are for video, data, data firehose, and data analytics. Let us see data streams. Amazon Kinesis Data Streams KDS is scalable and real-time data streaming service. KDS can continuously capture gigabytes of data per second from various sources such as financial transactions, social media feeds, IT infrastructure logs, etc. The data collected can be used with real-time analytics to expose anomalies, trends, and insights. These are the benefits. We have seen how it works. Input captured data is sent to Kinesis data streams. The data from Kinesis data streams is processed by the processing tools, and the output is sent to the BI tools. Some of the use cases are log and event data collection, real-time analytics, and these. Pricing. Pay-as-you-go pricing is applicable for this. There is no upfront cost or no minimum fee. You pay only for the resources you use. Pricing is based on two core dimensions, shard hour and put payload unit. Shard is the basis throughput unit of Amazon Kinesis data stream. We were talking about data streaming. What is data streaming? Data streaming is continuous generation of data by various data sources like log files, web transactions, financial transactions, social network feeds, instrumentation data, and from many more sources. This data needs to be processed and finds use in variety of analytics, including correlations, aggregations, filtering, and sampling. Analysis gives great insights on many aspects of business and hidden growth potentials. Amazon Kinesis dashboard. Let us sign into the console. Amazon Kinesis is under Analytics. This is Amazon Kinesis dashboard. Let us get started. We have seen four types of Kinesis usage. Ingest and process streaming data with Kinesis streams. Create delivery stream of data with Kinesis Firehouse delivery streams. Analyze streaming data with Kinesis Analytics applications. Ingest and process video streams with Kinesis video streams. Let us create a data stream. We need to know a bit of Kinesis data streams terminology. Kinesis streams speak of shards. Shard is a unit of throughput capacity. Each shard ingests up to 1 MB per second and 1000 records per second. A Kinesis data stream is a set of shards. A shard is a uniquely identified sequence of data records in a stream. A stream is composed of one or more shards, each of which provide a fixed unit of capacity. Each shard has a sequence of data records. Each data record has a sequence number that is assigned by the Kinesis data streams. A data record is the unit of data stored in Kinesis data stream. Data records are composed of sequence number and a partition key and a data blob. Data streams. Data streams terminology. Producers put record into Kinesis data streams. Example, web server logs sending to KDS. A consumer gets records from Kinesis data streams and process them. Kinesis data stream applications are easy to process records. The application can also send data to other AWS services. Consumer process the KDS application records and send output to Amazon S3, DynamoDB, Redshift, EMR, or Kinesis Firehouse. Kinesis client library (KCL) is compiled into your application to enable fault-tolerant processing of data from the stream. We'll be taking a demo on visualizing web traffic using Amazon KDS. Start the KDS application using AWS Cloudformation template. View the components of the application, data stream, producer, consumer, and KCL, and finally clean up. Prerequisites for this demo are sign up for AWS account, download libraries and tools. These libraries and tools will help you work with Kinesis data streams. Configure development environment. To use the KCL, we need Java development environment, which needs Java SE7 JDK, Java 1.7 or later, which can be downloaded from Oracle website. Other requirements are Apache Commons package, like code, HTTP client and logging, and Jackson JSON processor. Our demo is based on the AWS Developer Guide. In this session, we use sample application based on common use case of real-time data analytics. This sample application demonstrates the common stream processing use case of performing a sliding window analysis over a 10-second period. We use AWS Cloudformation template to get started quickly. AWS Cloudformation allows you to create templates to describe the AWS resources and any associated dependencies or runtime parameters required to run your application. The sample application uses a template to create all the necessary resources quickly, including producer, consumer applications running on an Amazon EC2 instance and a table in Amazon DynamoDB to store the record counts. Step 1. Start the sample application. Use AWS Cloudformation template. This is the Cloudformation template stored at S3. Cloudformation is under Management Tools. So these stacks we have. Let us create a new stack. In this we use a template that is stored in Amazon S3. This is the template. This is the template for our visualization sample application. Parameters, instance type, key name, SSH location. We are creating a stack, and creating a stack is in simple 4 steps. A stack is a group of related resources that you manage as a single unit. You can design template using AWS CloudFormation Designer to create or modify an existing template. Design template. We'll come back to this designer at a later session. Choose a template. A template is a JSON YAML formatted text file that describes your stack's resources and their properties. You can select a template or you can upload a template to Amazon S3. For now, we use the CloudFormation template in S3 provided by the AWS developer team. Next, specify details. Let us give stack name and configure other parameters. Let us use this stack name. This is application archive from the GitHub. Instance type t2.micro, which is under free tier. Let us provide the name of existing EC2 key pair to enable SSH access to the instance. If this is not provided, we will not be able to SSH to the EC2 instance. Let us see what is the existing key pair. Let us use this kpnu. SSH location anywhere. The IP address range that can be used to SSH to the EC2 instances. Click Next. We can specify the tags, key value pairs for the resources in our stack. Permissions. We can choose an IAM role that CloudFormation uses to create, modify, or delete resources in the stack. If we don't choose the role, CloudFormation uses the permissions defined in the logged in account. For now, leave default. Rollback triggers enable you to have AWS CloudFormation monitor the state of your application during stack creation and updating, and to roll back that operation if the application breaches the threshold of any alarms you have specified. Leave the default one. Additional options. SMS notification, terminate protection for the instance, a timeout, rollback on failure, stack policy. Leave defaults and click Next. Let us review the stack configuration. This is the template. This is the stack name. Let us see the estimated cost for this. We are using Linux on T2.micro instance. Estimate of monthly bill is $8.5. The options configured are these. Let us acknowledge that AWS CloudFormation might create IAM resources. We have a quick create option as well. This information is automatically filled and directly review and create. Okay, So check the acknowledge and create. This is our stack and create is in progress. It takes a couple of minutes for this stack to change status from create to complete. Let us see the creation of EC2 instance. It is running. Now stack is created. The status is create complete. This is the overview. This is the stack name, stack ID, termination protection disable, and this is the description. Counts table. This is the name of the DynamoDB table. Stream name. The name of the Kinesis stream. Application name. This is Kinesis client application. Instance ID. Instance ID of newly created Amazon EC2 instance. Availability zone. US East 1B. URL. This is the URL where the sample applications visualization will show up. The real-time data analysis graph appears on a separate page. Let us click this. This is the display of last 2 minutes of the counts as calculated by Amazon KDS Visual Sample Application for these URLs. These are the requests sent from referrer over 10 seconds, and this is the time. The chart is updated every 1 second and span of the graph is 2 minutes. Let us see the resources tab. This is the Elastic IP, EC2 instance ID, security group, and these are the other resources. This is log events. This is the Cloudformation template code. We can view or edit in Designer. Template we have seen, parameters, tags, stack policy, no stack policy. There are no executable change sets. There are no rollback triggers. Let us go back to Kinesis data streams console. This is Amazon Kinesis dashboard. We have one Kinesis data stream that is active. This is our Kinesis data stream sample application. We can configure producers to put data records into a data stream and configure consumers to continuously process data stream records. Open shards are 2, closed shards are 0. Server-side encryption is disabled. Data retention period default is 24 hours and can be increased up to 168 hours as per business need. Monitoring. This is monitoring info of the metrics, get records, put records. The graphs display the activity of the data producer putting records into the stream and data consumer getting data from the stream. A data producer submits data records to the Kinesis data stream to put the data into the stream. Producers call the put record operation on the stream. Tags, enhanced fanout. Consumers can opt in to use enhanced fanout for an additional cost. Let us see monitoring of Amazon EC2 instance. CPU utilization, disk reads, writes, network in and out, bytes, network packets in and out. Back to Kinesis. Our data stream. Data consumers retrieve and process data records from shards in the Kinesis data stream. Each consumer reads data from a particular shard. Consumer retrieves the data from a shard using the getShard iterator and getRecords operations. The data consumer creates a table in DynamoDB to maintain state information for the application. Each application has its own DynamoDB table. Let us open DynamoDB console, tables. These are the two tables created by our sample application. This counts DynamoDB table persists the results of the top N analysis over a sliding window. This KCL DynamoDB table manages state information. There are two entries in the table indicating the particular shard, lease key, position in the stream, checkpoint, and application reading data. Checkpoint, lease counter, lease key, lease owner. Kinesis client library. Consumer applications can use Kinesis client library (KCL) to simplify parallel processing of the stream. The KCL takes care of many of the complex tasks associated with the distributed computing, such as load balancing across multiple instances, responding to instance failures, and reacting to resharding. The KCL enables you to focus on writing record processing logic. This is our KDS visualization sample application. We started the sample application. We have viewed the components of the application. Let us do the cleanup. Delete the KDS sample application. The shard application creates two charges which incur shard usage charges while the application runs. To save unnecessary costing, delete your AWS Cloudformation stack when they are no longer needed. Let us go to Cloudformation. Our KDS sample app. This one. Action. Delete stack. Click yes. The delete in progress. This stack is deleted. DynamoDB tables are deleted. Let us see the EC2 instance. No running instances. That's about Amazon KDS. There is a wide application of KDS and easy integration into the existing analytics infrastructure. This is dashboard, creating stack, stack creation in progress, data visualization, DynamoDB tables, EC2 instances, data stream monitoring, stack creation, stack deletion. In the next session, we use AWS CLI to perform basic KDS operations. Thanks for watching.